Hello, I'm Richard Patterson and welcome to another video presented by IPC Science. And in this episode, we're going to look at these items of equipment which are going to be used to look at the infrared end of the visible spectrum. We've also put the UV lamp here. It's part of the same area of teaching. And we've also got the infrared probe here, which can be used to have a look at the range and intensity of radiation by coupling up to a voltmeter. The IPC Irwin Radiant Heat lamp is a compact and safe heat source for investigating infrared radiation. And in this graphic here from the CLIAP site, we can see some of the safety instructions. And infrared, of course, is non-ionizing. It's got a wavelength of about 10 to the minus 5 meters. But of course, it can produce skin burns, and strong sources may damage even the cornea of the eye, and it can ignite combustible materials. But in our experiments here, providing we don't touch the cowl, it's a very safe piece of equipment to use. So it comprises a base and a cage, and inside is a specially custom-made lamp, 300 watts, which is of the dull emitter type. Practically all the 300 watts is converted into infrared radiation, and I can feel that with my hands as I just get close up to it. It's not too hot. The unit can take about half an hour to reach maximum temperature, so you need to take that into account when you're planning your lessons. And the cage has been placed around the lamp just to warn pupils that it will be hot, even though the lamp doesn't visibly emit any light at all. Knowledge of infrared is in every popular science specification as part of learning about the electromagnetic spectrum. So what is infrared radiation? Well, this graphic shows you where it sits relative to the other types we need to study. It's below the visible spectrum, and it's got a wavelength from around 700 nanometers up to 1 millimeter. Now, our eyes can't detect it, but we can feel its presence when it falls on our skin. So the simplest experiments for our students are where we ask them to use their hands and their wrists and their cheek to detect it. And we can also investigate what happens when we insert screens of glass and solid insulators in between the radiant heat lamp and our skin. So, to run a class practical for infrared, set up the lamps around the room and warn the students of the dangers of getting burnt if they do touch the metal cage. I've used the screen from the IPC colour mixing apparatus here, so we now have an aperture, a hole, and the infrared radiation will travel out through here, and we can use parts of our body to detect it. So I can use the back of my wrist or palm of my hand there. A more sensitive area is to use my cheek. I can feel the cheek being warmed by the infrared coming through the hole. So get the students to try that out and perhaps give them a worksheet with a few investigations on it. They can use an insulating materials and like putting that over the hole, removing it, over the hole, removing it. They can think about the time it takes for the heating effect to be experienced again. And it should, of course, be instant. Another thing they can try is to get a sheet of glass and see again if that has any effect on the intensity of the infrared radiation through the hole. So in these experiments, we've avoided the use of special detecting instruments such as infrared probe or a thermopile, and we're just relying on the simple use of the student's skin as a detection device. Students should notice that the infrared appears to travel in straight lines through the hole here, and as they move their head from side to side, the heating effect is cut off, and so is the infrared. We can use a device to detect infrared radiation, and this is the IPC Irwin infrared probe. Now, mounted in the plastic casing is a phototransistor, and it's responsive to the infrared spectral. So we're basically repeating what we did with our hand or our cheek. We've aligned the infrared probe with the hole in the screen, but this time we're looking at the output on an Irwin 0.2 volt DC voltmeter. And you can see it's getting a response now with the probe really close up to the radiant heat lamp. If I slide an insulator in between, you should see the response on the voltmeter drops instantly. And if I remove it again, there we are. It's responding very, very quickly to my insulator, blocking and restoring the infrared light. Finally, we can get a sheet of glass and try that and see if there's any effect. And I think you can see that the voltmeter reading just drops ever so slightly, telling us that the infrared is not absorbed by this particular material significantly. Well, thank you for watching our video. As usual, we've got our QR code, and you can access the IPC Irwin training site and look at the specifications for using the radiant heat lamp and the infrared probe. We've also added the Institute of Physics Spark links. There's a wide range of experiments that we've not had time to cover in this video. You can find out how to recreate Herschel's experiment using a prism and the infrared probe, and you can use the Leslie's cube to investigate the relative emissions of dark and shiny surfaces. And there's one classic experiment using curved mirrors where we can focus infrared radiation between a pair of curved mirrors in a similar way to when we're using curved mirrors, concave mirrors with visible light. We also added a link to the CLIAPS site where you can find out safety information dealing with apparatus like this.